Car air conditioning, a system that maintains the temperature and humidity inside the car at appropriate levels, is essential for comfortable driving. In this video, you will learn the properties of a refrigerant, how the refrigerant changes its form as it circulates through the system, and what will happen if the proper amount of refrigerant is not present in the system. Before we study about the flow of refrigerant, let's review the locations of air conditioner components and see how they are connected to each other in an actual vehicle. We will use a Corolla as an example. This is a compressor. The compressor is connected to a condenser by pipes and hoses. The condenser is connected to a receiver and dryer unit. The receiver and dryer unit is connected to an expansion valve. And the expansion valve is connected to an evaporator. These main components are connected by pipes and hoses, and a cooling gas or refrigerant flows through these components, pipes and hoses. Now, let's study about the refrigerant. We are looking at a glass container holding a refrigerant. The container has been placed on a block of ice, but the refrigerant seems to be boiling. In fact, it is evaporating. Let's put the refrigerant in this container now. This container is not on ice now, so the temperature must be much higher than in the scene we just saw, but the refrigerant is not boiling at all. Do you know why? It is not boiling because, as you can see here, it has been put under pressure. These two experiments show two things. One, that a refrigerant evaporates easily, even at low temperatures, and two, that it liquefies easily when put under pressure. These properties of a refrigerant may be illustrated by this graph. This line represents the pressure that is applied to the refrigerant. This line represents the temperature. And this curved line indicates the border between a liquefied refrigerant and a gasified refrigerant. A refrigerant becomes a gas when both the temperature and the pressure are above this borderline. It becomes a liquid when the temperature and pressure are below the borderline. When a refrigerant turns to a gas, it requires evaporation heat. Let's test it using a rose. The refrigerant has taken so much heat from the rose that the flower has frozen completely. Let's now study how the refrigerant works in a car air conditioner. Generally speaking, it takes heat from the air inside the passenger compartment as it evaporates in the evaporator, and it discharges the heat to the outside of the vehicle when it is liquefied by the condenser. The refrigerant is forced to flow under pressure through the system by the compressor. In this animated illustration showing the flow of the refrigerant, the red indicates the flow of pressurized refrigerant and the blue the flow of the unpressurized refrigerant. An actual car air conditioning system consists of these three components plus the receiver and dryer unit and the expansion valve. Now, based on what we have learned so far, let's see how a refrigerant actually changes into a gas and back into a liquid again. This is special equipment we have designed so that we can actually see the flow of the refrigerant when the air conditioner is operating. Flow of the refrigerant begins from the compressor. The refrigerant that was gasified by the evaporator is pressurized by the compressor. Let's compare the pressure before the refrigerant enters and after it leaves the compressor. The pressure increases to 15 kilograms per square centimeter at the exit of the compressor. Now we will closely examine the refrigerant before and after it is pressurized by the compressor. First, let's see what the refrigerant looks like before compression. As you can see, the refrigerant looks like a mist. In other words, the refrigerant flows in the form of a gas. This shows the refrigerant after compression. It appears as if the refrigerant remains the same before and after compression. In other words, the refrigerant enters the compressor as a gas and exits from the compressor as a gas also. Let's check to see if there is any difference in the temperature of the refrigerant before and after compression. The temperature has increased from 13 to 94 degrees centigrade after compression. Let's go back to the graph showing the relationship between temperature and pressure. Since the measured pressure is 15 kilograms per square centimeter and the measured temperature is 94 degrees centigrade, the refrigerant is a gas. If the temperature is lowered enough, we should be able to change the gasified refrigerant into a liquid. The hot, pressurized refrigerant is sent from the compressor to the condenser, where its temperature is lowered. The refrigerant in the condenser is cooled by the air while the vehicle is running, or by the cooling fan of the vehicle. Let's measure the temperature of the refrigerant at the entrance and the exit of the condenser. As you see here, the temperature is lowered substantially by the condenser and the refrigerant is turned into a liquid. In other words, the refrigerant discharges the heat that it collected from the air in the passenger compartment to the outside of the vehicle. We will now see how the refrigerant changes its form from gas to liquid. The refrigerant being sent to the condenser is still very hot and generally looks like a mist. In other words, it is usually a gas when it reaches the condenser. As it flows through the condenser for some time, the majority of the refrigerant becomes a liquid containing some gas bubbles. This is the refrigerant at the exit of the condenser. A completely liquefied refrigerant is normally transparent. As you can see here, the refrigerant has turned almost completely into a liquid. Liquefied refrigerant is sent to the receiver and dryer unit next. A receiver and dryer unit has two functions, as its name implies. It stores and dries the refrigerant. This is an actual receiver and dryer unit cut in half. This is the drying section where water and dirt are removed from the refrigerant. The refrigerant is dried and cleaned by the receiver and dryer unit, after which it is sent to the evaporator by way of the expansion valve. Let's measure the pressure of the refrigerant before and after it enters the expansion valve. The refrigerant is sent from the compressor under high pressure, but the pressure is reduced substantially by the time the refrigerant leaves the expansion valve. The pressure is reduced by the expansion valve so that the liquefied refrigerant can be changed into a gas by the evaporator. At the same time, the expansion valve adjusts the amount of refrigerant to maintain the cooling capacity at an optimum level. We will now see how the amount of refrigerant can be adjusted. The expansion valve is connected to a heat-sensitive tube that measures the temperature at the exit of the evaporator. When the air in the passenger compartment is hot, hot air flows through the evaporator. So the temperature of the refrigerant at the exit of the evaporator rises. The heat-sensitive tube sends a signal to the expansion valve telling it that the temperature is high. The expansion valve opens up the refrigerant passage so that a larger amount of refrigerant is permitted to flow through the evaporator. On the other hand, when the temperature of the air in the passenger compartment is low, cool air passes through the evaporator. The temperature of the refrigerant at the exit of the evaporator drops as a result. The heat-sensitive tube sends a signal to the expansion valve. And the expansion valve reduces the valve passage accordingly so that a smaller amount of refrigerant is allowed to flow through the system. The expansion valve increases and decreases the valve passage repeatedly in this way so that an appropriate amount of refrigerant is supplied at all times. We will now examine how the air is cooled by the evaporator. First, we will see how the refrigerant changes in the evaporator after its pressure is lowered by the expansion valve. This is the refrigerant near the entrance to the evaporator. At this stage, the refrigerant is almost completely liquid. But by the time it reaches the middle point of the evaporator, the amount of liquefied refrigerant has decreased substantially. This is the refrigerant at the exit of the evaporator. The liquid has disappeared, and the exit is filled with a gasified mist. In other words, the refrigerant has evaporated completely. Let's compare the temperature at the entrance and at the exit of the evaporator. The temperature of the refrigerant is 4 degrees centigrade at the entrance and 6 degrees centigrade at the exit. Assuming that the temperature of the ambient air near the evaporator is 40 degrees centigrade, the air temperature is lowered by 36 degrees near the entrance and by 34 degrees near the exit by the evaporation of the refrigerant. There is a fan in back of the evaporator. This fan sends cooled air into the passenger compartment. In this way, the evaporator takes heat from the air in the passenger compartment by evaporating the refrigerant. The completely gasified refrigerant returns to the compressor to start a new circulation cycle. Now, let's review the cooling cycle and see how the refrigerant cools the air in the passenger compartment. The refrigerant takes heat from the air, thus becoming a gas. It is compressed by the compressor to help it easily become a liquid. But simply compressing the refrigerant is not enough to turn it into a liquid. The refrigerant gas becomes a liquid when it is cooled by the condenser. And the heat taken from the air by the evaporator is discharged outside the vehicle by the condenser. The liquefied refrigerant is stored in the receiver and dryer unit. Dirt and water are also removed from the refrigerant by this unit. The pressure is reduced by the expansion valve. This valve also adjusts the amount of refrigerant supplied to the evaporator. Then the refrigerant again takes heat away from the air in the passenger compartment as it is turned into a gas by the evaporator, and the cycle starts over. We have studied about the basic function of the refrigerant in a car air conditioning system based on the assumption that the proper amount of refrigerant has first been supplied. Now, what will happen if the amount of refrigerant in the air conditioner is not enough, or if there is too much? Let's remove some of the refrigerant and see what happens. You can easily imagine that the air conditioner's cooling power will be less if there is not enough refrigerant in the system. But why is this so? When the amount of refrigerant is less, there is naturally less refrigerant in the receiver and dryer unit. For this reason, much of the refrigerant is a gas when it reaches the expansion valve, as you see here. What happens in the evaporator then? When there is not enough refrigerant in the system, a greater portion of the refrigerant is a gas near the entrance to the evaporator. And most of it is a gas in the middle of the evaporator. Naturally, it is still a gas when it leaves the evaporator. In other words, if there is only a small amount of refrigerant in the system, it completely turns into a gas by the time it reaches the middle point of the evaporator, and no evaporation occurs near the exit of the evaporator. This means that the refrigerant is not taking heat from the air. Now, what happens if we put in too much refrigerant? Let's put in another can of refrigerant and see what will happen. The receiver and dryer unit is now filled with the liquid refrigerant. The high-pressure side of the compressor is 10 kilograms per square centimeter higher than the normal level. Such a high pressure sends far more than enough liquid refrigerant to the expansion valve. Let's see what happens in the evaporator then. Most of the refrigerant is a liquid near the entrance. And much of the refrigerant is still a liquid at the midpoint of the evaporator. We can still see some liquid near the exit where it is supposed to have been turned completely into a gas. In other words, the amount of refrigerant is so much that it cannot evaporate completely before it leaves the evaporator. This means that the refrigerant is not taking enough heat from the air, similar to a condition when there is insufficient refrigerant. These experiments show that the air conditioner's cooling capacity is affected if the amount of refrigerant is either not enough or is too much. In this video, we have studied the basics of the refrigerant as a first step to learning more about car air conditioners. We have learned that we must put the proper amount of refrigerant in the air conditioning system. This is because the cooling capacity is affected if the amount of refrigerant is either not enough or too much. We have learned that the car air conditioner functions normally only when the refrigerant is liquefied and gasified normally. When you service a car air conditioner, please remember what you saw and learned in this video. We are certain that this video will prove to be very helpful to you in providing Toyota customers with quick, reliable Toyota after-sales service.